who have joined on a very, very interesting and important topic. Obviously, as all of you know, the title is Modern or Latest Technologies in Corrosion Mitigation and Sustainability. Friends, it's a wonderful day. There is rain in some parts of Maharashtra, and all the more reason to bring attention to a critical subject like corrosion, about which we are going to be engaged in for the next 2 hours. And once again, a warm welcome to all of you. We shall be taking question and answers at the end. And for more on this, Jen sir, over to you for the introduction of EFC.
Hello. Good afternoon, everybody. I welcome you all on behalf of Epicon Friends of Concrete. It is a knowledge sharing platform since 1999. Next. This activity is conducted under umbrella of Epicons Consultants Private Limited, which is ISO 9001 2015 certified company. Our one of the well-defined objective is imparting technical knowledge to society and interested parties at large. And in our vision, we say that let Epicon be synonymous with safe, optimal, and sustainable structures. Next. The inspiration goes back to our friend, philosopher, and guru, late engineer A.P. Remedials, and we started with that. Further, when we adopted the word sustainability in our vision, we tried to contribute from our side to the 17 goals decided by high-level political forum on sustainable development. 11th goal is sustainable cities and communities. Next. Recently, we had Think Beyond Green Part 2. And what we can do as a structural engineer, civil engineer, is to intervene in carbon missing and also take action at appropriate stage. So one of the appropriate stage is a 5 installation and assembly, and second appropriate is replacement and refurbishment. So whenever we construct concrete structure, right at the time of construction, we can act ourselves in proactive manner, and whenever we are going for repairs and refurbishment, we can adopt the modern technologies. Next. EFC has conducted 84 workshops in past 24 years and 44 webinars. Now it is 45 webinars in last 4 years. Started webinar series since lockdown through our unit EFC dedicated to training. These are the 2 photographs of physical workshops conducted in past 55 and workshop 70. EFC is an humble effort to create knowledge sharing platform and develop a facility for continued education for practicing architects, structural engineers, corporate consultants, governments and government authorities, builders and developers, and of course, faculty and students. Next. Today we are at webinar 146, latest technologies in corrosion mitigation and sustainability. And the next program we are proposing on earthquake engineering. It might be a physical program on 18 January 25. Next. Now our team, apart from myself, we have Anand Kulkarni, Ravindra Deshpande, Arvind Parulekar, Parashar Mughe, and P.P. Pandey. For all the webinars and workshops, they are involved from concept to completion. Next. And with this, I thank you all on behalf of my all family members, company members who contributed for webinar. Thank you. Next. Avi preamble.
So thank you, sir. I request Arvind Parulekar to give the preamble of today's function.
Yeah, good afternoon, friends. Welcome to Epicons Friends of Concrete webinar 146 on latest technology in corrosion mitigation and sustainability. We will be deliberating various aspects of the subject for next 2.5 hours. Corrosion. The world doesn't need any introduction for civil engineers, designing, constructing, and maintaining all kinds of structure. As we all know, it is the single largest phenomenon which is the root cause of deterioration of any structure, be it concrete or steel. And hence, corrosion mitigation measures to reduce the risk due to corrosion during designs, material selections, construction, or during service life is a topic of concern to the engineers who are associated with all these aspects of civil engineering. Today's speakers will be elaborately dealing with all these aspects of corrosion mitigation and latest technologies related to the same. You may be wondering why this word sustainability is there and what these measures have to do with sustainability. Well, we need to be aware that sustainability is the keyword which encompasses every aspect of the human life, and corrosion mitigation is no exception to that. In 2015, world leaders came together at UN to set up 17 goals of sustainable development. Just now, Mr. Jain Kulkarni had shown you the slide of that. It is expected that every action of every entity as well as human being in the world should contribute to one or more of these goals. Out of these, 11th goal is related to sustainable cities and communities. It is required that our built environment should be more durable and long lasting, as we will be spending much more energy in demolition and reconstruction of the same if we do not make it durable. The corrosion mitigation measures are the saviors in ensuring durability and hence contribute towards these goals. At the same time, it is required that these measures themselves should not consume more energy, and the research is aiming towards the same. We will be deliberating a few of these aspects today. So friends, without taking more of your time, we'll start our sessions today. Thank you very much. Over to Priya.
Thank you, sir. That was very lucid. And a little about my company, Wide Angle Forum. We are a company based in Pune, and our job is to connect creative minds. And I mean everybody who works in the design, lifestyle, and construction industry. Next. So we have 5 arms in which we work. One is the main flagship company called Design Vista, called Wide Angle Forum, where we do presentations, interviews, talk shows, so many events we do. And it's a matter of pride for me that I'm associated with Epicons Friends of Concrete at wonderful occasions like this. Next. So we have a design magazine. It's a national pan-Indian magazine where we feature projects, work by architects, and information. Next. We have an academy called Aspire where we do a lot of things from grooming young minds to helping them get jobs, connecting them with stalwarts, and of course, participating in workshop and sessions such as these. Next. And of course, one of my favorites, which is study tours. We go to sites, we go to meet wonderful people, wonderful projects, both outdoor and indoor. And we have a lot of fun on the way and a lot of information sharing also. Next. The last and very important, a book club, which is the think tank of society. Yesterday itself, we had a nice function. A book does not mean only a book. It basically means experiences and expertise. So that's something that also we do regularly. Next. Yes, so friends, that's it about us. Now, to start with, which I was about to tell in my welcome speech also, from school times, we have all been fascinated by this iron pillar that in Delhi, which it seems was built by Chandragupta too, and which has not rusted yet. So, since then, every Indian has been proud of our own heritage of being really good ironsmiths, and that has stayed with me right to the moment where this very webinar was being planned. And I thought, wow, how exciting it would be to talk about a subject like corrosion in the year 2024. So this it's my great honor to be introducing our 3 speakers for today. As you all know, each speaker has been given a specific time, and of course they will stick to the time. But if it's okay, sir, I will remind you 5 minutes before your speech that 5 minutes to go. So on this note, it's great to introduce our first speaker for today, friends. Please welcome Engineer Prem Prakash Pandey to the gathering. A little about his academic background, as you can see on the screen, a BE Civil, presently Unit Head PMC Division at Epicons Consultants Private Limited. It's great to know that stalwarts such as these have a mix of qualities. For example, the skills that he possesses, of course, an excellent knowledge and exposure of various types of civil engineering projects, at the same time, a good understanding of basic chemistry and concrete technology, friends. How great is that? That however techno savvy you are, you have to know the basics. Sir has delivered several lectures on his very favorite topic, which is concrete technology, of course, the durability, quality control, and other aspects. His special skills are very much seen in various large areas like budget development, negotiation, project management, risk management, strategic planning, Microsoft Office, and all the admin things that we need for a day to day functioning. He has handled number of projects which are very important both for the nation building part as well as for the urban infrastructure or the urban landscape, as you can say. And as you can see on screen, a man with various diverse skills. But of course, today, friends, what we are going to hear from him is his contribution to the concrete technology, specifically to understanding how and why of corrosion. Prem Prakash Pandey, sir, over to you. And I think you have 30 minutes, 5 minutes to go. I will remind you. Over to you, sir.
Hello, am I clear?
Yes, sir.
So, thank you for so lofty and generous introduction. I am flattered. So, friends, welcome. Next slide. I'll be putting my thoughts on no. Why do corrosion protection? Please skip the slide. Why do corrosion protection methods for RCC need to evolve continuously? Next slide. Corrosion of iron is not new. You see, in human civilization, there was a Stone Age, Bronze Age, and then Iron Age. And discovery of iron is almost 3,500 to 4,000 years old. Variously, it is considered that it was developed in some part of North Africa. Some say that it was in Sumerian world. But leave alone that, the history is quite old. And the use of iron was very much important for maritime development. I mean to say shipping industry, or you say seaworthy ships were all made of hulls were made of iron, and they faced this problem of corrosion some 250 300 years ago. And the people, they found out various solutions like using copper, zinc, various kind of coatings, coal tar coatings and oil coatings, etc. So this struggle is quite old. Moving ahead, oil and gas sector, these are mostly in the coastal areas and they face this corrosion problem, and they have developed methods like anodic protection, cathodic protection, impressed current protection, so many things. Further use of iron is in reinforcement concrete, RCC, and this has become extremely important for all aspects of development. And now we are making various kind of structures using RCC. In future, maybe probably there will be floating RCC cities. That these concepts are going around. Next slide. But along the development, we noticed the industry has realized that RCC is a cancer called corrosion. As Parlekar sir has told, that corrosion is the single most deterioration factor for RCC buildings and steel structures. And since then, the race is on, the fight is on, the fight with corrosion. how to stop it, how to reduce it, how to mitigate it. And the industry has developed some basic ideas about prevention. Now, if you remember, it is generally understood that RCC building in the past used to last longer. Our corrosion used to take place at much longer duration than what it is being today. And that fact is because we were using mild steel in the initial stages. And the mild steel has less corrosion probability or potential than the steel which we are using today. The thermomechanically treated steel, whatever we are using. Previous slide. No, previous slide. Yeah. The serious problem is started when we produce steel with higher tensile strength by using chemical manipulation and pre-stressing the steel by cold twisting or pinching. For many of you, it might be that information may be surprising that the steel which we are using in RCC today, they are provided stress. They are pre-stressed by way of either cold twisting. Now these kind of bars are no more in use, or quenching, and this is the process which is used maximum nowadays. So steel is already given some kind of strain to become stronger. Next. Now the basic corrosion fighting mechanism, what we used to do some time back, that to fight corrosion we had simple formulae. Dense concrete, that is as low permeability as possible, proper cover, all our codes they define minimum cover for various elements because the depth of cover is one of the defining characteristic of RCC element for durability. Third is regular maintenance, like painting, and also to keep the RCC elements away from dampness, away from stored water, etc. Now, for a long time, we were putting stress on these three things, and these were effective too. But it has come to our notice that these are no more sufficient. They are effective, but not sufficient. Now, let us try to know why it is not sufficient, why we need to evolve, why we need modern and different technology. Next. There are probably four important factors. There may be many, but I have listed only four factors. One is that constituent materials are changing. Cement is getting finer and stronger per unit weight. Steel is doing the same thing. Chemical and physical properties are changing. Second is performance demand is changing. Earlier, RCC structure used to be quite humble, and now we are making massive structures using RCC. And such kind of use demands different kind of physical and physical properties and performance criteria. Third is that environment is changing. So it is very obvious that industrial pollution, vehicular pollution, and all kind of pollution is changing the composition of the environment to which RCC is exposed. Fourth is that understanding of material property is changing. That is with invention of computing, new mathematical, statistical approaches. They are all new kind of microscope, all kind of testing equipments, X-rays. These are also giving us insight into material physical properties, which we did not know earlier. So these are the factors which are this thing making it necessary to evolve our understanding of corrosion. Next slide. Now, change in material properties. Now, let us say cement. Some time back, we are using cement grade 33, then came 43, then came 53. Thereafter, number of microfines. There are microsilica, fly ash, GGBS, and many other kind of additives are there. Now, pH retention time is reducing as more material gets consumed faster. Now, why? Because we are using finer material, more of the surface area is available for hydration in a shorter time. So if you are putting 400 kg of 33 cement, and if it takes complete hydration to take place, say for 60 days, now for 53, the same thing will be done in 15 days. So more of material is being consumed, and therefore pH retention time is also reducing. Reinforcement, if you take reinforcement, is the same issue. We used to have 315, then 415, 500, 550, 550D, then probably 600, and next will be 650. And this property or the performance of steel is being achieved some by chemical manipulation and other by changing the crystalline structure of the steel by introducing pre-stress in the steel. And one fact is known very much in mechanical industry, that higher the working stress, higher is the rate of corrosion. The term which is used in this study is called stress corrosion. Any material, any at higher state of stress is prone. This is because of change in material property. Next slide. See, this is just a table to tell you that OPC 33, 43, 53. Then comes PPC, PSC, rapid hardening cement, hydrophobic cement, low heat Portland cement, sulfate resistant Portland cement. So these are the things changing. Then there are other fine materials. There are n number of additives. Next. These are pozzolanic material which are mixed in the concrete. Say fly ash, GGBS, rice husk, metakaolin, microsilica. These are added in various percentage and they change the physical property of concrete, the rate of gain of strength of concrete, the electrochemical environment of concrete is also changed because of this. And electrochemical environment is one factor which affects the rate of corrosion. So all these admixtures, chemical manipulations, they have effect on corrosion. Next. 33, 43, 53, various properties. Next. Now, second is that performance demand is changing. So ever increasing scale of structures, I will show you the photograph. What exactly is happening that physical properties are being modified using new materials, as I said, pushing the limit of working stress to fatigue threshold. Almost we don't go to that extent, but it is going towards that direction. And concrete is subjected, RCC is subjected to higher stress level than what it used to be some 50 years ago or 60 years ago. Environment is changing. I will show you some photograph. Carbon dioxide is increasing, fossil fuel due to fossil fuel consumption. Sulfur acids are also increasing in the atmosphere. Sometimes there is acid rain. And when I say increasing use of untrained or poorly trained workmen, I take it as an environmental factor. In construction industry, the demand is so high, the demand of development, that there is an acute shortage of trained workmen. And that is being fulfilled by partially trained or untrained people. And because of that, some very important factors like maintaining cover, proper cover, all along the elements are RCC structure, quality of cover because of very heavy reinforcement, because there is a commercial pressure on keeping thin members, thin columns, thin beams, especially in the residential sector. These are the environmental pressure, I will say, including the commercial or pressure for designing structures which have inherent potential of deficiency. And all this has to be taken into account while we think of mitigation rate of, I mean, say, corrosion. Next. See, this is just a pictorial representation to show you that, you see, earlier concrete, when it was RCC was developed, it was for very humble structures, 1 story, 2 story, is it kept on increasing. Now we have got 200 meters, 300 meters tall buildings. And not only buildings, we have got huge bridges, chimneys, cooling towers, and this is a sea isle platform in the sea, which is made of concrete. And you can see there is a small city on that. It's a huge structure, and it goes more than 90 or 110 meter into the sea. So these are the kind of environment and extreme exposure which concrete has to face, RCC has to face nowadays. Next. Pollution, everybody is suffering from pollution. We keep on hearing about Delhi, most polluted city, and there is a pollution around Mumbai, in our MIDCs, in everywhere. We have vehicular pollution within Mumbai, and this has become a fact from which we cannot run away. I will say this is a side effect of the development, and the development cannot be stopped. So this environment will keep on changing. Next. Next slide. Now, lastly, understanding of material property is changing. See, earlier, cement and steel, we were only able to study some kind of physical property, some kind of chemical composition, and our all understanding of the use of the material, to what limit that material can be used, what causes the failure of the material, what is the limit of failure of the material. These informations were quite sketchy in the beginning. As the technology advanced, we got computing power. Large computers, fast computers, having great computing ability. Then we have various kind of microscopes, electron microscope, and all this development has given us much more insight into property of the material. Now we can see the crystals, how crystalline material form, like in case of steel. What is the amorphous molecular structure of cement, and how this we have. Now we are talking about, not we are talking about microscopic understanding, but we are talking about nanoscopic understanding of material. So you will see in the next slide. Next. Now you see this is a microscopic view of cement paste, concrete. Here we can identify each and every crystal, silicates and aluminates, various formation. In the right side, you will see that fibrous thing which are hydrated cement particles, tentacles coming out of the cement particles, which are important for binding property of the cement. The forces which is called van der Waals forces. These forces are surface attraction forces because of the closeness of the different molecules, and these are other than electromagnetic forces. These are developed because of the close proximity of different molecules. Now this is the kind of understanding we are having, how actually the cement develops binding property, what kind of crystal formation is there, how we can increase those kind of fibrous elements and crystals which create better strength or better bonding. And that is giving us ideas about making cement more efficient. Next. See this optical microscopy. By this you can see the pores can be identified, hydrated particles can, this thing, outer products, that is interface between aggregate and cement paste. All this can be seen far better understanding of the material. Next. See, this is a electron microscope photo of surface of cement particle. Can you imagine that what kind of insight the science is giving into understanding of material? This is mind-boggling, and this is helping the scientists and the production engineers to create new technology for better material, for better chemical manipulation of the material. So this is changing the material properties of the material like anything. Next. This is just a sample graph. This is, see, generated by computer. There's so many data. We can create graph which was manually cumbersome earlier, and various kind of statistical relations which we can explore, and sometimes we get some new insight which was not available before. We could compute data and explore the trend of the data, which is very much important for producing material with great consistency. See, in all engineering structure, the consistency in the behavior of the material is very, very important. Our all design is based on assuming certain consistency, certain repetition of the behavior, certain percentage of failure. And more data we have, more and more experiments we do, more and more practical data we gather from the field, better understanding we have of the material, and as I said earlier, better we can push the limit, and we can make the material perform at higher stress level. Though the side effect is that in case of RCC, pushing to higher stress level means also making it prone to corrosion. That's exactly what we are discussing. Next. This is another example of, say, computer generated graphs. You can just imagine that without a computer, understanding pattern or something of so much data is almost beyond normal human beings. So these kind of computing is giving us a different insight into the behavior, physical behavior, chemical behavior, whatever property we want to be studying. And this is helping, or this is um, prompting people to have better material, more efficient material, stronger material. And that's the way. I mean, so that's the way ahead. That's the development that cannot be reversed. And it has side effect. And that side effect has to be um, uh, mitigated. And those other means are also being facilitated by technological advancement, by better understanding of material like additives, polymers. We have much better understanding how plasticizer works, how viscosity modifiers work, how waterproofing admixtures work, because we can see their molecular structure. We can see how they change the properties of concrete, and that's the race going on. As the concrete is changing, cement is changing, steel is changing, as the use is changing, it is creating an environment where corrosion is faster. And similarly, corrosion fighting mechanism is also evolving, changing. We are getting new insight, and therefore there is new kind of material, organic material, inorganic material. Some of the methods which we are using may not be new. Next slide. So some of the methods, say for example, use of say zinc. Now, use of zinc is as old as shipping industry, when steel ships with steel hull were constructed before the steam ships. And the major problem was the hull corrosion of the hull, because it used to be in the seawater. And then people started using zinc as a mitigation measure, because and we know that galvanizing has uses zinc. So, and galvanized iron was is quite old technology. It's not a new technology. However, use of zinc as a sacrificial anode in concrete is not. It may be very recent in our country, but it is for a couple of decades in Western countries which face corrosion as a major problem. So some new, whatever we call latest technology, are repurposing of well-known methods, and they are being brought into the building. Similarly, like say vapor capsules, these are organic capsules. They provide some kind of vapor. They get into gel pores as a vapor is spread, and they got affinity towards steel, so they coat the steel and they create a barrier. Now this particular compound was used in shipping industry for transport of steel, uncoated steel products, and these kind of compounds were put in the packaging to prevent corrosion during months and months of transit over the sea. Now we are repurposing it to use in RCC. So some of the latest technology may not be very new kind of product or new kind of invention, but it may be repurposing. Whereas use of corrosion resisting additives, some kind of additives are added into concrete as a corrosion inhibitor. They are of course new inventions. And so the modern or latest technology is a mix of old wisdom repurposed for the new situation. And many a times from different industry we learn something and then we bring to our industry and how it can be used, things like that. So all these things are going on, and this race with the corrosion, I don't think it is going to end in near future, because as the properties of concrete and properties of cement and steel keep on evolving, as the corrosion fighting mechanism will keep on evolving, so they will have the race with each other for quite a long time. Next. So thank you, gentlemen. I think I have completed in time or before time.
Thank you, sir. You have completed little before time. And I
Yeah.
really found it interesting the way you took all of us through the reasons for corrosion. And you even mentioned this interesting thing about the need for the hulls of ships to be protected. Also, India has had a rich maritime history. So I found all that very interesting. And therefore, I think all of us are very eager to go to the next part where Saraswati ma'am will be actually getting deeper into this how to prevent the corrosion happening. So anyway, thank you very much for that. As we always do, we'll be taking the questions at the end of all the three talks. And therefore, I'm very happy, ladies and gentlemen, to welcome you to the next speaker. It's a great pleasure to introduce her. And here goes. So Dr. V. Saraswati, an academic background of BE, and she's the Chief Scientist, Corrosion and Materials Protection Division at the Central Electrochemical Research Institute for so many years since 2013. And a prolific author, obviously a much sought after speaker, particularly in a topic like corrosion. And in fact, it's interesting, ladies and gentlemen, to know that she has patents, she has written in international journals, a transfer of technology where she has contributed through knowledge in technology happening somewhere, and of course, several national and international projects. I'm told more than 100. So this is so great, isn't it? I'll come a little. One of my favorite areas is where you have somebody who is a speaker and has won awards. So Saraswati ma'am has been honored with more than 12 different awards, all based on her rich and deep knowledge of corrosion, has headed bodies like the National Corrosion Council of India. She was chairman of this, has worked deeply with government and semi-government institutions, including the very prestigious ONGC, and of course, friends, has played important roles in the structural assessment of structures of national importance. This is so important considering that what we earlier spoke about sustainability being very important to prolong the life of a structure. On this note, Saraswati ma'am, we are so happy to have you here. Just to inform you, you will be speaking for 45 minutes, and 5 minutes before your talk, I will be reminding you. Just before you start, I would like to bring the attention of people to know that Saraswati ma'am has worked on the Tungabhadra Dam, the life assessment. We would like to know a little about that also. So anyway, without further ado, Saraswati ma'am, over to you. Please start.
Good afternoon, and thank you very much for your nice introduction. I will be presenting on the topic corrosion protection technologies. So today's theme is modern technologies as corrosion mitigation and sustainability. Why? Why we have to mitigate corrosion? Because corrosion is like a cancer. So if we are not controlling corrosion, then we can't make a sustainable structure. So to make the structure more sustainable,
Madam, you have shared the screen, or you are?
yeah, I will share.
Yeah, please.
Is it visible?
Yeah, yes. Yeah. Just make it full screen, madam.
Yes.
Yeah, please go ahead.
So today's topic is corrosion mitigation and sustainability. Why we have to mitigate corrosion? So if you are mitigating corrosion, you are making the structure more stronger, more durable, and more sustainable. How to make it? So using durable materials, or if you are using the same material for a long time, it may get depleted. So you have to use some alternate materials. Then adapting sustainable design, then implementing the proper quality control techniques, then periodic monitoring of the structures, and also periodic maintenance and adapting suitable protection technologies. So the loss due to corrosion is said to be around 2 to 4 to 5% of our GDP. So the loss is are divided into direct loss and indirect loss. So direct loss include cost of the structure, equipment, machinery, material, and other maintenance cost. So the indirect cost includes plant shutdown, loss of production, loss of valuable products, etc. So if you are adopting some suitable technologies, you can save 25 to 35% of the cost by using the corrosion mitigation latest technologies, and also by creating corrosion awareness among the industrialists and also consultants and other society through conducting seminars, workshop, and webinars like this type of get together. So I am not going very deep into corrosion because now I have more slides. So corrosion mechanism. So if you are exposing the material in the environment, it gets corroded by using the atmospheric contaminants present in the atmosphere. So iron is more, if it gets oxidized, it is 6 times voluminous than the parent material. So volume gets increased and ultimately the stability of the product is getting affected. So the corrosion is classified into dry corrosion and wet corrosion. So dry corrosion is a slow process, but wet corrosion is a fast process. It took place at high temperature, but dry corrosion takes place at a low temperature. So like these are all the common slides which I am not going to share. These are all the the common forms of corrosion that everybody may be knowing. That normally what we are using is mild steel. So mild steel is suspected to be uniform corrosion. So pitting corrosion, where it is if you are using stainless steel in the chloride environment, it will lead to pitting. So like that, all these types of corrosions are the familiar corrosions. And majorly this SEC corrosion is stress in the presence of environment. It is causing stress corrosion cracking. So it is that is present in the underground pipelines and other important structures. So how the classification of environment is based upon ISO 12944. So normally the classification of environment is divided into C1, C2, C3, C4, C5, and CX. So CX is the extreme corrosive environment. So it contains that offshore may contain high salinity, industrial, as well as humidity is also high. So normally we are encountering with the industrial with high humidity and aggressive atmosphere, which is C5 environment. So C6 is the recently added environment in the code ISO 12944, which is said to be the extreme environmental conditions. So if we are using some paint, and if you are using some paint in C1, C2, C3, C4 or C5 environment, you have to test that paint as per ASTM B117 to know whether it is having how many lives of how many the durability, to know the durability, how many hours it is getting passed. So if it is passing 1440 hours, then the paint is the paint may be durable over 7 years. So if it is passing over 2000 years, then we are saying that no, the paint may last for 7 to 15 years. So based upon that observation, we made the observation that if the paint is passing 1440 hours, the paint will last for seven years. So if it is passing more than 1440 hours, the paint will last for 7 to 15 hours in the highly aggressive environment as per ASTM B117. So this is the durability of the paints what we have tested, and high durability paints, that we can't guarantee any paint that is having higher durability, but as per standard it has been given that high durability paint will be last for 15 to 20 years. But as per the prevailing situation, no paint will last for more than 15 years as far as my experience is concerned. So these are the corrosion protection methodologies. Normally we are following some paints and coatings, inhibitors and cathodic protection. So other than that, these are the most followable methods. So paints and coatings, whether it may be temporary or permanent protection, it will give temporary or permanent protection. So inhibitors may be anodic, cathodic, mixed inhibitor, VPA inhibitor, and green inhibitor. So these are all the examples of anodic inhibitors and cathodic inhibitors, mixed inhibitors. Recently, we are using bipolar inhibitors also. That is like mixed inhibitor. Nowadays, we are using bipolar inhibitors also. So in cathodic protection also, sacrificial and impress current system we are using, and anodic protection we are using for a particular protection of structures, and alternate improved materials also we are using for depends upon the environmental conditions. So the what is the difference between paints and coatings? So paint is we are using for decorative application, and the coatings we are using for barrier come permanent protection. So paint is for temporary protection or permanent protection, but coatings are used for extended life of service. So these are all the common terms which I am using. This I am not going to discuss in detail. So this is a corrosion inhibitor, how it works. So corrosion inhibitor is divided into organic and inorganic inhibitors. So organic and inorganic inhibitors, again, it is classified into anodic, cathodic, and mixed inhibitors. So various types of inhibitors are available in the market, and also depends upon the environmental conditions, or depends upon our requirement. We have to choose the right inhibitor for our structures. So anodic inhibitors give passive protection, and cathodic inhibitors give barrier protection. So this mixed inhibitor gives both barrier as well as passive protection. So these anodic inhibitors give the mechanism is physisorption, and cathodic inhibitors, the mechanism is chemisorption. So physisorption in the sense physically absorbed on the surface. The film is physically absorbed on the surface to protect the material, and chemisorption is chemically bonded with the material and it protects the base metal. So again, sacrificial protection, the previous speaker has talked about it, but the SICRI, we have developed a sacrificial anodes for the protection of ship hulls, then jetties and the other underground pipelines also. So normally the sacrificial anodes are used for protecting the underground pipelines as well as the jetties and other important structures. So it need not require any external input or external power supply. But for impress current system, it needs external power supply. So this is a major difference between this sacrificial system and impress system. In sacrificial system, sacrificial anode, we are using the most sacrificial anodes as the like magnesium, aluminum, and zinc as the anode. In impress current system, we are using more noble metal as the anodes, like TSAA and other graphite and other anodes. We are normally we will use carbon steel also for using as the anode for giving the impress current sacrificial system. So this is the comparison between sacrificial and impress current system. This I am not going to. So in SICRI, we are dealing with corrosion materials protection division. We are dealing with almost all the protective methodologies. So concrete corrosion, we have developed inhibitors. Cathodic protection, we have developed our own anodes. Biocorrosion, we have developed biocides. Inhibitors also, we have developed both for oil and gas industries. And we have been doing the failure metallurgy and failure analysis of the underground gas pipelines and other important structures as far as the industries are concerned. So our main unit is placed in Karaikudi, and another small one unit is placed at Rameshwaram. So this unit is said to be the highly corrosive zone in Asia. So we have collected the corrosion rate by exposing various materials over a period of 10 years, and we have collected the corrosion rate, and we found that this site is said to be the most corrosive zone in South Asia. So we have carried out the extensive corrosion map of India by exposing these materials all over India by selecting 56 exposure stations. And we have done a 93 to 2004, we have done a corrosion map, which was very highly useful to almost all the industries. So these are all the technologies developed by SECRI, and all these technologies are in service, and all these technologies are sustainable technologies, which has been and which is being used in almost all the important structures like bridges, then rails, then monuments. So one by one, I will explain. So this first one is a cement slurry coating. So this cement slurry coating consists of inhibitor plus cement. So this is a 4-step process, and this technology has been used in the Palman Bridge, which is located near the Rameshwaram. This is the birthplace of our president, past president, ex-president Abdul Kalam ji. So this bridge is coated with inhibited cement slurry coating for the rebars, and presently it has been coated with the 4-coat system for protecting the concrete external concrete surface. So both the technologies were developed by SECRI, and till today the bridges withstanding are sustainable because of the SECRI coating, which has been given inside for this, both for the steel rebars as well as for the concrete surface. Once in 4 years, the CPWD is implementing the 4-coat system for the entire bridge structure, and we are going there for the site to make the quality control of the bridge. These are all the other structures which have been protected with the cement slurry coating. So this is a MGR Memorial, which is located in Chennai, and this Kongan Railway, the entire bridge was constructed using our system, and Rameshwaram TV Tower. So like that, so many important structures have used this cement slurry coating, and still it is maintaining its sustainability. So this is the improved version of cement's polymer composite coating. Here it contains cement plus polymer. That is the earlier system contains cement plus inhibitor, that is water-based coating. This is cement plus polymer coating. So this has the added advantage of flexibility. So previous coating does not have that much flexibility, but this coating has the flexibility. And this system has been implemented in more than 70 flyovers across India. So this has all these characteristics, features. So other for this 4-coat system, which is developed and implemented in Palman Bridge, has been implemented to some other bridges in Thane Creek Bridge, New Mondavi Bridge, and other cooling towers wherever it is located very near to the sea, or it is surrounded by some industrial environment. So this 4-coat system contains epoxy polyamide iron oxide, epoxy polyamide MIO, and epoxy polyamide TiO2, and epoxy polyamide aliphatic. Each and every coat has its own significance. For the initial first coat, which gives addition to the concrete surface, and the second coat, it gives barrier protection, and third coat TiO2, since it contains TiO2, it is highly weather resistance and breathing capability, and aliphatic polyamide, which is highly UV resistant. So this is the system which we have recently tested. This 100 years old bridge under construction, reconstruction is going on in Rameswaram. This is the railway bridge. So first time in India, they have used stainless steel rebars for the construction of piers and pillars, concrete piers and pillars, and they have used this metallizing zinc epoxy, these two type of coating for the entire bridge, including the lift span. We have tested this coating at Sikri, and we found that the system performs well in this harsh marine environment. So this is another important structure called Talla tank, which was constructed during the British period, and recently it has some corrosion issue. They have approached us, but the strengthening of the structure was done by the government of Bengal and the nearby engineering college, and also we have recommended to use the internally the food grade epoxy, and externally we have advised them to use the zinc rich epoxy primer as well as polyamide epoxy as well as UV resistant aliphatic polyurethane for the external surface. For internal surface, we have recommended to use the food grade epoxy, since they are using the drinking water purpose. The size of the tank is very big. It is more than a football size ground, and they have completed the renovation. Now it is kept under that use. So this is another important structure which is located in Chennai, that is North Chennai Super Thermal Power Project, which is under construction. So this is the tallest cooling tower in India, which is located very near to the sea. So we have recommended to use the high build epoxy, which was developed by Sikri, that is moisture compatible high build epoxy for the inner shell, and for protecting the outer shell, we have recommended to use the 4-coat painting system, which is developed by us, and they have implemented this technology, and it is under now commissioned recently. So this is another important technology we have developed for the Trivandrum, the ISRO. Normally they are using coal tar epoxy for the temporary protection of that this high vanadium emerging steel for their for storage purpose, but the coal tar epoxy is found to be highly carcinogenic, and internationally it is banned. They requested Sikri to develop coal tar epoxy. We have developed a epoxy based phenolic coating for the protection of this vanadium steel. So we have developed it, and we have tested in our own Mandapam, that is Europe. But now they wanted us to develop the equivalent technology. We have developed it, and we have developed that coating, and we have tested as per all the standards, and this technology has been transferred to them, and they were successfully using it now. So this is another important cathodic for cathodic protection. We are using this sacrificial anodes for protecting the ship hulls and underground pipelines and jetties. This technology was developed by us, and this technology has been transferred to many of the licenses across India, and they have been using this technology for protecting the offshore jetties and other important pipelines. And this is another important technology which has been developed by Sakri for protecting the thermal coatings for hydroclaves. This technology is also for ISRO. We have developed it, and this is a silicon composite, high temperature silicon composite coating. This was developed by us, and this technology has been transferred to ISRO. And this is another important technology. So normally we use solvent based paint removing jelly, but this technology is environmental friendly technology. We have developed it, and for while removing the paints which ISRO is using, because we have developed our own epoxy phenolic coating for the temporary protection of their steel products. So they wanted this paint removing jelly also for removing that product while using it again. So this technology is also developed for them, and this technology has been transferred to them. So this is another important technology for the concrete structures. This is highly based on inhibitor. So normally we are using Portland pozzolana cement. It contains 25 to 30% of fly ash. So fly ash contains some carbon and sulfur. So it creates corrosion. It creates corrosion of rebars. So to protect that, we have developed this corrosion resistant inhibitor, and this technology has also been transferred to many technologies, many licenses across India, and they have been using it for some erection of electric poles and other important structures. So this is another one important project which I was involved in. This project when it was under construction in 2000. I stayed over there for a long 2 or 3 years, and we have installed our own sensors. This is a first bridge, cable stay bridge built in Naini bridge, and this bridge was commissioned in 2004. And during that period, we have installed almost all the sensors, accelerometer, vibration sensor, all type of sensors, and the corrosion measurement sensors were made by us, and these sensors were also installed in that bridge. And over 5 years we have monitored that bridge, and that bridge was handed over to the government. So this is another important projects which I have taken part, which is Kudangulam nuclear reactor, Kega reactor, Tarapur nuclear reactor, that we have developed our own sensor, that is integrated sensors. And earlier we have been importing that sensor from abroad. After that, we have developed our own integrated sensor, and we have placed that sensor in the dome for monitoring corrosion, then chloride, humidity, resistance, and other parameters. So this is another atomic power station which they have used our own sensors. So this is another important project which we have carried out for the RDSO. Normally during the morning hours, due to the excreta and urinals, they are getting the rails are getting corroded. So for that, they want us to develop a coating, and we have developed 3 types of coating, and we have tested in the rail over a period of 1.5 years, and we found that the epoxy zinc phosphate primer and coal tar epoxy top coat is performing better, and we have handed over this system to the RDSO. And this another important project we have carried out for the Sardar Sarovar Dam project in Gujarat. So our scientists between 2011 to 2016, so 18,000 tons of steel were left over in the ground. While they wanted to use it again, the government approached us, and we have carried out an extensive survey through 5 years, and we have we have recommended to use that 90% of the plates can be used for the construction of the dam. So they have we have submitted the report. Based upon that, they have used all the spillway gates and other steel products, and they have the bridges, the dam is under commissioned 2011 itself. So this is another important projects. So because we have carried out the previous project for this Sardar Sarovar dam project. So after that, they made one among the member as the dam safety board member. So their approach recently, steel minister visited the Tungabhadra dam. So it is 70 years old, and they want us to examine whether the life of the structure can be extended or it can be abandoned. So normally the life of the structure is only 45 years, but we found that we don't find any single piece of material left over for examining the quality of the material. We should not touch, we should not damage any of the steel, but we made our own measurements, our own that is cavitation measurements and other non-destructive measurements, and we found that most of the spillway gates and skin plates it will last for another 50 to 60 years. So the government, they are going to save nearly 300 crores by making such type of assessment, among which my team and myself visited the site. We stayed over there and we took all the measurements, and we have submitted the remaining life of the dam. So this is another important project. Everybody knows that this Thiruvalluvar statue is located in Kanyakumari, that is 133 feet height, located in the middle of the sea. So it is getting, due to the high tides and low tide, it is getting eroded. So to prevent erosion, they want us to have some of the protection technologies for preventing the erosion. So we have recommended to use silane siloxane based coating. So once in 4 years, they are doing the renovation and we are supervising it. And along with the TTDC and archaeology department, I was made one among the member of the expert committee. And once in 4 years, they are doing it and we are monitoring the structure. And this is another important structure, Adiyogi statue, which is located in Coimbatore. This black color coating is recommended by us. So this is the largest bust in South Asia, and the weight of the statue is 500 tons. So this is a type of coating which we have recommended, and they have used it, and they are also recoating the statue once in 4 years. So this is this integrated sensor gadget developed by us, and this has been implemented in Kudangulam nuclear reactor, as well as the single sensor we have installed in almost all the, that is NFC Hyderabad, then zirconium sponge plant, even in Naini Bridge we have installed single sensor for monitoring the corrosion rate of the steel. But this sensor gadget contains 5 or 6 parameters, but now we are implementing single sensor for measuring the corrosion rate as well as potential. We are implementing the sensor also in NFC Hyderabad. We have installed this sensor in Hyderabad. So this is another important project which we have recently completed. This is the railway project, that is Chennai Metro project. So they have been encountering with the rail corrosion as well as hook corrosion issue. So we went there, and almost all the tunnels also they are encountering with the seepage issue. So we have recommended to use suitable coating. After making the measurements, we have recommended, they are using the some other type of coating. So we have asked them to modify the system, and now they are implementing it. During implementation, we are supervising that is quality control of the painting system. So these are all other important projects which I have been one among the member of my team. So Indian Oil Corporation, they have encountered with some corrosion issues. So we have recommended to use the cathodic protection system for the existing tank bottom. So far they have not implemented any cathodic protection system for the existing tank bottom, which has been corroded and repaired with some new plates. So they have been implementing, and we are going to monitor the CP for the existing tank bottom. This is another important project we have done for the petroleum storage tanks of the BPCL plant. They are also having some corrosion issues, internal and external corrosion issues. They are using some different kind of paint. Now we have asked them to modify the glass plate type of coating to use for the internal and external system. They are using 9 different type of coating, and we have given the modified recommendation for them. This is another important technology which we have developed recently, and this has been implemented to some of the schools in and around our village. So this is another important projects. This for Indian borders. Some of the borders are located in the agriculture area, and some of the borders are located in the acidic environment. For them, we have recommended to use we have collected some fence materials from different companies, and we have evaluated that, and we have recommended some 2 or 3 important type of combination of coating, and we are recommended to use that coating. CPWD is implementing that coating, and during that implementation, we are monitoring it. it. So this is, as I said, we have a trust called National Corrosion Council of India. So it was started in 1990. So far we have conducted 40 conferences and 40 conferences and seminars and other workshops. So during that period, in 1993 itself, we have started this corrosion map of India, and over 57 field exposure stations we have exposed the materials, and that materials have been taken over a period of 10 years. The corrosion rate was collected, and that corrosion was classified as severe, moderate, and low corrosion zones. So we found that the corrosion is site specific data, and we have exposed over some 4 or 5 materials, and we have collected that data, and it was circulated to many of the industries. After that, we have not updated the data. Now we are approaching our CSAR for the updating of the corrosion map of India. So these are all the conferences which we have conducted. See, in addition to that, we are conducting the industry-oriented courses for the benefit of the industries, as well as for the benefit of the students, academic persons also. So we are based upon their request, we are making the tailor-made specialized program for their requirement. So these are all the technical programs and refresher courses we are conducting, and skill development program. Every month we are conducting 1 or 2 program for the benefit of the that students as well as academic persons. So this is the updated corrosion map of India. We have collected 57 exposure stations. We have exposed 4 different type of material: mild steel, zinc, galvanized steel, and aluminum. We have collected the data, and this collected data was highly useful to the industry. But now entirely the climatic condition has changed. We could not able to, since many of our senior staff, they have retired, we could not able to go ahead. Now we are approaching our government as well as the oil and gas industries. They are, and also many of the NTPCs, they are also willing to come forward to place our expose our materials and collect the data. So now we have started collecting the updated corrosion map of India data by exposing our materials in few locations. So thank you very much.
Thank you, ma'am. That was really wonderful. And 45 minutes, you took us through so much. You took us through the technologies to prevent corrosion. You talked about wonderful projects, including flyovers and bridges and beautiful buildings and tanks that are 113 years old, thermal power, and so much. I'm not going to go through all that now. So just to summarize that, whatever you told us was not only was it full of technology, but as an architect myself, I found it so interesting that corrosion can be such an intense topic, and yet what it does to the beautiful structures is amazing. So friends, thanks a lot, Saraswati ma'am, for that. And this is the point in time when we will be giving some time to our sponsor from Construct Chem. And I request Dr. Atul Bedekar to come up and give us 20 minutes of his talk. Before that, I would like to introduce him. Dr. Atul Bedekar, an academic background, has done MSc and PhD. And for the last 35 years, Atul has been working as a consultant for product development and quality management for a range of chemicals and allied products. As a PhD research guide and associate professor in colleges, he has also been involved in academia and also has been working for developing symbiotic industry academia interaction. I find that very, very interesting and very important because, as over the world, we always want industry experts who are deeply involved in interaction with the educational forums, with students, and with everybody who wants to be interested in harboring a really healthy construction climate. So, Dr. Atul Bedekar, over to you. You have 20 minutes and your time starts now. Please go ahead.
Thank you. See, as informed in my introduction, primarily I come from academic background, but I had opportunity to have some insight into civil engineering because of my association with Epicons for almost more than 30 years now. For today's presentation, the topic which we have used is the development and quality control of products for corrosion mitigation. Today's focus of our attention is prevention or minimization of corrosion of steel used in construction. To address this problem, today large number of products are available, commonly known as construction chemicals. In this presentation, attempt is made to throw some light on development and quality control of these products. The presentation also includes information about products of Construchem used in corrosion mitigation. In earlier presentation, you heard a lot about which products are recommended for different corrosion related problems. But why those products are to be used with their ingredients and content, which need explanation. Today, engineers and architects refuse to buy your product as a black box. They wish to know that what goes on, what science and technology has gone into development of those products, or what can assure quality of those products which they are advised to use in the corrosion related problem. So today we are going to talk about that when any corrosion related or for the solution of corrosion related is found, the development of any good quality product start with understanding definition of quality. This will help us in knowing that what goes into the corrosion, the chemicals which are developed for prevention of corrosion. Talking about quality, it is ability of product or service to satisfy needs of the customer and consumer to their satisfaction and delight without any side effect for intended duration at affordable cost. Now, this definition is applicable not only to chemical products, but all the products or services which we come across. If we think about this definition in terms of civil structure, we find that for intended duration part, most of the civil structure are expected to last for more than 30 or 50 years. And that is where the problem of corrosion is more important. Over a period of time, the concrete structure is expected to give a same quality performance from the date of its from the date it is erected. So, in present context, the product must have ability to prevent or minimize corrosion. Customer may be engineer or architect. In the definition of quality, we have mentioned about satisfaction of customer and consumer. Now, customer is the one who select the product depending upon its properties. And consumer is the one who normally uses the product. So the quality of the product should be such that it must have ability to satisfy both customer as well as consumer. Now, selecting a product or selecting the product, a consumer is a contractor using the product. Now, as far as the side effect of these corrosion related products are concerned, it may be safety and handling in these products, or effective duration for such product should be as long as possible. Being a commercial product, cost should be competitive. Now, when we are thinking about the information which must be given to our prospective buyer, that what are the considerations which has gone into development of the product? The steps of product development involve design qualification, installation or application qualification, operational qualification, and performance qualification. When any chemical product or formulation is developed, It is based on well-defined correlation which exists between properties of matter and physicochemical composition. In our earlier presentation, we have already come across talk about this correlation between the property of matter and its physicochemical composition. In this context, it may be of interest to mention that as far as the phenomena of corrosion is concerned, we have talked a lot about why corrosion occurs because of the environmental factor and so many other factors. But primarily corrosion occurs because of the thermodynamic factor, which says that iron oxide, which is product of the corrosion, is more stable than iron. And therefore, it's a spontaneous process. And under the favorable condition, it is going to occur. Okay. Apart from that, for talking about the correlation between the properties and the matter in the phenomena of corrosion, as far as the steel which has gone into construction, after the corrosion, whatever steel which was put into the structure, column or beam, is still very much there. But what has changed is that now iron exists in the form of iron oxide and not iron anymore. And because of change in this physicochemical composition, the properties which were assumed for the iron while doing the structural calculations are not valid anymore. And that is the reason corrosion can lead to failure of construction. Now, the term physicochemical is used in properties depend only on the chemical identity, but also on the physical constitution. In the earlier presentation, it was mentioned that mild steel is less prone to corrosion than the pre-stressed steel it is used. I was not aware of that. So any change, physical change in the steel also leads to corrosion ability of the steel is a new information for me. The term physicochemical composition used the example of diamond and graphite are both chemically carbon, but differ significantly in properties because of different in physical constitution. See, the product made to meet quality requirements may be mixture of different components selected on the basis of their properties. Now, what we are talking about, that what consideration go into development of a product which are used in mitigation of corrosion. Okay. Now, when such product is developed, it may not be made up of one single homogeneous component, but may be made up of large number of different components, which will make the final formulation. After clearly understanding the quality requirement of the product, next step is selection of appropriate ingredients based on physical and chemical properties. For example, silica is selected as a filler because it is chemically inert and physical state chosen is microfine to make structure dense. After selection of all components at qualitative level, next step is quantitative. It determines the percentage of each constituent in the formulation. In two-pack formulation, the relative proportion must be decided. Next step is selection of appropriate equipment and methods to blend all the ingredients. After the design qualification, when you have decided, you have selected all the required components in qualitative and quantitative way, the next step is application qualification, which decides suitability of the product for use by testing parameters like viscosity, spreadability, or usable life of pack of product after mixing. The area where product is to be used may not be easily accessible. A factor should be considered while application qualification. In product used for coating, thickness of coat or sequence of coat in multi-layer product should be mentioned. In earlier presentation, there was a talk of four-coat product or four-coat formulation, which is to be used for prevention of corrosion, to be used in particular sequence. Here, what matters is that what are the ingredients chosen for those coats and why they have to be ordered or applied only in that particular order. How exactly, what is the mechanism of their action if the order is reversed or the composition is changed? That is the kind of information now users are looking for. Any product to be used in the form of spray, which should be tested for its ability to use as a spray. After product has cleared design and application qualification, it is subjected to operational qualification. Now here, performance of the product is measured under controlled conditions. Normally, acceptance criteria are decided in advance for the quality of the product. After operational qualification, product is subjected to performance qualification, where the product is tested in real-life situation to decide its quality. After this test is performed, the product is cleared for marketing if passing in standard tests like ASTM. So this gives us the path through which any construction chemical goes through before it comes into the market. Now, after performance test is satisfactory, the last step is preparation of standard operating procedure, that is SOP, and document it to ensure reproducibility of the quality in all the batches, which is most important because no chemical, what comes into the market comes in the form from different batches. And to ensure reproducibility of quality in all the batches, all steps involved in manufacturing process are chronically listed with all the details and approved by competent authority. All of you may be aware of what is a good manufacturing process. This documentation forms part of GMP. Now, this is the part mainly related to what goes into the development of products which are used in the mitigation of corrosion. Now, as far as the selection of content is concerned, for mitigation of corrosion, I have not talked about what are the factors which govern corrosion or what factors should be taken into account. That as far as corrosion is concerned, it may consist of electrochemical corrosion or chemical corrosion. Electrochemical corrosion consists of 4 components: cathode, anode, electric current, and ionic current. While selecting a product or designing the product, these 4 parameters are taken into account, and accordingly, the components of the anti-corrosion formulation is selected. As far as protection from chemical corrosion is concerned, the main approach is to prepare a coating which is impervious and which may be in the form of paint or any other form of coating. And there need to be ensured that it is impervious. Once the product is developed, the next important aspect is quality of that product. Because any buyer is interested in knowing that whether the product is of good quality or not. Now, quality control is possible by performance test, as in case of electric bulb. When you want to test the quality of electric bulb, you simply try to see whether you put it into socket, whether it is lighting or not. See, but particularly in case of product related to civil engineering, such kind of performance tests are not possible. And therefore, product is subjected to certain qualitative and quantitative tests. For many products, standard tests are available from BIS or ASTM. In many cases, such tests are not available when in-house analytical method development, standardization, and validation is carried out. The quality control is based on determination of some limited parameters for few samples and finished product. So this gave rise to the concept of quality assurance. See, now all this talk is important, particularly in case of products which are used in civil engineering or construction chemicals, because very little information is about quality management of such products. Now, in quality assurance, what we do is to introduce testing start from the raw material, and all the steps manufacturing are monitored by testing intermediates. In quality assurance, it is mandatory to document every activity. Anything which documented is not documented is considered not done.
Sir, 5 minutes to go.
Okay, thank you. Total quality management, the next step is total quality management, which cover the department, the next step in quality is total quality management, which cover departments of the company. All the efforts are made to satisfy customer and consumer. Okay. As mentioned earlier, in this presentation, I wish to give you introduction of the products of company which cover different product like Corroguard. It is designed to provide protection against corrosion for various civil structure, designed for new and old structure of residential building, columns, slabs, and beams in corrosion structure. Corroguard B, it is designed to provide superior protection against corrosion for various structure in highly corrosive and aggressive saline conditions, specialized mortar covering with having pH 14, specially designed for water retaining structure in high saline condition. Corroguard S, it is designed to provide superior protection against corrosion of columns jetty in high corrosive and aggressive saline condition, specialized mortar covering with having pH 14, specially designed to column cooling towers, bridges, structure, dip C. Corroguard tablet. Corroguard tablet is bipolar corrosion inhibitor designed to protect metal surfaces, reinforcement bar from corrosion and enhance the concrete durability. It forms an ionic layer over steel bar, puts the negative charges ions from the metal surface. The best advantage is that it's effective in humid and conditions. Corrosion guard, liquid-based corrosion inhibitor, rust guard, alkaline-based rust converter, steel guard, zinc-rich primer, struck guard, MIO, anti-corrosive intercoat for steel structure. Corrosion guard, liquid-based penetrative bipolar corrosion inhibitor. Corrosion guard is applied as an impregnation by spray, rollers or brush or to the surface of the concrete. The corrosion inhibitor penetrates into the concrete and protects them from cement by forming a protective film on the steel surface. Advantage is helps to degenerate the anode and cathode over steel bar by forming ionic layer over steel bar. Rust guard, an alkaline-based rust converter. Rust guard is a single component liquid that removes rust and prevents rusting of steel structure by providing passivation coat. Advantages: convert rust into stable inert substance, stop rust progression, prepare surface for coating or painting. Steel guard epoxy-based zinc-rich primer. Steel guard is 2-pack epoxy-based metallic rich primer designed as an anti-corrosive primer for protection of steel. Advantages: easy to apply, fast curing, good bonding to metal, high weather resistant. Struck guard MIO. Struck guard MIO is 2-component epoxy-based reinforced with MIO pigment for improved corrosion resistance and extended temperature resistance. It is basically designed as intermediate between struck guard zinc primer and struck guard PU top. Mainly developed this product for steel structure and pipeline. Structure repair. Repair guard, fiber reinforced corrosion resistant thixotropic repair mortar. Repair guard epoxy mortar, epoxy based anti-corrosive repair mortar, grout mortar, epoxy LVMT, low viscous moisture tolerant. Struck guard CR, corrosion resistant micro concrete, mainly manufactured for construction, repair or structure in highly saline corrosive environment. It avoids the ingress of chloride ion and provides high strength. Repair guard F, fiber reinforced corrosion resistant thixotropic repair mortar. Repair guard F is general purpose non-stick concentration thixotropic high strength formulation for structural concrete repair. Other extremely low permeability water, carbon dioxide and chloride. Repair guard epoxy mortar. Repair guard epoxy mortar is a non-shrink and high mechanical strength properties epoxy-based anti-corrosive mortar. It is 3-component system comprising of base hardener and quartz filler. Advantages: creates good bond between structural element, non-stick epoxy mortar, high mechanical and adhesive strength. Ground guard epoxy. Ground guard epoxy LV is a low viscosity epoxy system comprising of hardener with mixing ratio of 2:1. This system has an excellent bond with concrete structure and can into the finer cracks present in the concrete. Advantages, it resists the chloride and negative ingress of chloride ions. Ground guard epoxy MT. Ground guard epoxy MT is an low viscous moisture tolerant two-component epoxy system comprising of resin and hardener. This system has an excellent bond with concrete structure. Advantages, it provides anti-corrosive protection in wet condition. Structural guard carbon. Struct guard carbon is a carbon fiber used for anti-corrosive structural strengthening of beam column applicable with struct guard and struct guard saturated. Advantages, stop the chloride ingress and resist the corrosion of structure. Struct guard glass. Struct guard glass is a high strength glass laminate used for structure strengthening. Advantages, it stop the chloride ingress and resist the corrosion structure. Struct guard Pro PU coat. Struct guard Epo primer, moisture. Struct guard monovat and struct guard coal. Carbonation guard, anti-carbonation protective coating for concrete. Carbonation guard is a single component 100% pure acrylic-based elastomeric coating based on acrylic dispersion with excellent crack beaching and anti-carbonation with anti-corrosive properties. Permeability carbon dioxide is low. Advantages, preventive protection for reinforcement concrete structure exposed to aggressive and corrosive environment. Struct guard Pro PU coat. Struct guard Pro PU coat is high build two component. This product is suitable for Struct guard Pro PU primer guard Pro intercoat. It provides a durable high gloss. Advantages, high resistance coating used in industrial and architectural coating system. It is popular in marine industry and used for Struct guard Epo primer. The Struct guard Epo primer is high build two component moisture resistant corrosive epoxy primer coating. Application, cooling tower, jetties, marine and offshore structures, industrial facilities. Struct guard Novo coat. Advantages, it provides the structure from corrosion from heat and inorganic acid. Struct guard cold guard. Advantages, it provides outstanding anti-corrosive performance with excellent fresh and seawater resistance. Struct guard TPO. Application areas, factory sheds, warehouses, and cold storages. Airport railways, metro and bus transit station. Corrogard UCL. Corrogard UCL is bipolar corrosion inhibitor. It has best application for storage tank, completely underground pipelines for gases, oil, and water. A perforated or slotted tube is drilled under the tank, pipeline bottom, and UCL is injected as a powder slurry into the sand bed soil. Thank you.
Wow, that was really very interesting. And friends, there are two things which I'll take away from Atul's talk. One was when he very interestingly said that coal or a form of coal and diamond are basically the same. It's but the composition which is very different. And the second that you said thing that you said, which I found very interesting, is that how do you test the quality of an electric bulb? Well, you just put it in the socket. If it's on, you know it's a good, but it's very different for products like this. So, friends, before we move on to our next and third speaker, let's all collectively appreciate the role of the engineer, the contractor, the project consultant, the products that are used in every single construction. Another thing, next time you either go to a seaside resort, whether it's in Goa or Maldives, or you're on a cruise ship, let's take a minute to appreciate the nuts and bolts that has gone inside whatever we are experiencing in an environment of salinity. So, moving on to our third speaker, we are good on time. It's a great honor and a privilege to introduce the third speaker, who is an architect. So, architect Roland Mendonça, a creative person, highly skilled, 40 strong years of experience, that you're talking 4 decades. The world has changed in 4 decades. So it should be interesting to see what he says on the topic of mitigating corrosion. In a complexity of projects, Rollin has contributed in a range of typology from diplomatic missions, commercial complexes, banks, educational institutions, blood banks, hospitals, residential townships, railway terminals, really a wide array of projects and all kinds of end user projects. Rollin is also known for his innovative and organic style of design, inspired by nature and a strong passion for high quality, client focused architecture, friends. It's important to note here that he's very good in the sector that we usually call as legal and rescue, where an architect can contribute so much to a sound fraternity and a sound building climate and landscape. He has rescued and completed projects that have been stuck for years and somehow decades, and rescued them and brought them back on the track. Rollin believes that architects have the power to protect and enrich people's lives by designing the world around them through detailing. I find that so interesting and so important. He has set out to do just that while he sits at the helm of the Mendonça Group, which is a one step solution and a one stop solution for full service architectural design and build consultancy. Rollin, of course, has a proven track record of success while navigating and steering the collaborative confluence of consultants and contractors. Throughout this seminar, we have spoken about a seamless understanding and synchronization of every element of construction, right from the conceptualization, the design, actually making it happen till you start using it. And therefore, I find this very important. His in-depth knowledge and application of mind has made him a storehouse of information, especially for the students that he lovingly teaches and finds time for at the Sir J.J. College of Architecture, and of course as the design chair of VCAAD. After giving this very short introduction, Architect Roland Mendonça, over to you. We are all very keen to hear and watch what you have. Over to you. You can start your presentation. You have 30 minutes and the time starts now. Please go ahead.
Thank you, Priya. It's very appreciative of Epicons for inviting me to speak at this webinar. I have with me our staff here. So Anil will start with the presentation.
See the screen share. I don't see it.
While Anil is just trying to get the sharing option, I will just say a few words. I'm thoroughly impressed by the information that we have received and the sharing of knowledge by the speakers. I would like to mention to you that we have picked about 9 case studies, which we will go through to explain to you how our design has been inspired by nature and in a very organic manner. I must also mention to you that I have known Mr. Jayant Kulkarni since 1978, when he was our engineering professor at the Sir J.J. College of Architecture. And there were some important messages that Kulkarni sir had given to the students at that time. And most importantly was that he mentioned that while you are studying the subject of engineering, you as architects must remember that the engineering part of it, the structural part of it, is like the bone in your body. And a thought came to me that it is such a sacred part of the body, because everybody knows if a bone is broken, the beginning of the end of life starts. And therefore, I began to look at nature, at the human beings, at animals and birds, and how their structure has been protected by the flesh and the skin around. And I always remembered this in our design, that the skin around the human body, around animals, birds, is something that protects their structure. And therefore, when we are designing, it is only fair that we as architects use this knowledge and this awareness to put a skin around the structure that is being designed by the structural engineers. Now, the challenges that we face is that different clients have different needs, different projects have different requirements. There are statutory laws which govern all types of design. And as architects, we have to actually look at the entire scenario before we put our structures onto the ground. Right from the beginning of the foundation, we have to make sure that the entire structure is like an envelope. It covers the entire building. And you will see through the slides that there are different types of structures, different types of systems that have been incorporated, different types of materials that have been incorporated, and the different types of requirements of the municipal corporations that have been incorporated. We all know that from the earliest of times, there used to be structures that were only load-bearing. And after the load-bearing structures began to see the use of concrete, maybe 100+ years ago, it was something that excited the whole world. But one thing we all know, that although concrete is such a beautiful material and it can shape all kinds of projects, it also has the vulnerability. And the type of frame structures that we construct in India, in Mumbai, in coastal areas as well, has its vulnerability. It is not the fault of the concrete, it is not the fault of the engineers who have designed it, but it is the environment that the structure is in that contributes to its life and its lifespan. It was mentioned earlier on that the iron pillar in the north of India has stood the test of time for so many years. And corrosion today has become a very important aspect that we are not able to control. And therefore, we have understood that in order to make...
Excuse me, Roland, he's facing any problem? Shall I share? I have got the PDF copy.
2 minutes.
If you want, I can share.
What is 2 minutes?
Sharing in 2 minutes.
Sure.
It is sharing in 2 minutes.
Yeah.
Why does it say that?
So why should
Technical.
I think there is some technical message which has come that it will share in 2 minutes. But
Okay.
if you have the live presentation,
I have, but I have a PDF, so it will not move properly. So if he's sharing, that's fine. Otherwise, I'll share PDF. Yeah.
It is sharing.
Yeah.
Pardon, you said it's sharing in 2 minutes. So why you are not able to share?
That option is not showing up here.
I believe Anil says the option for sharing is not showing up on...
No, it is there. Please just move your cursor at the downside. You will get a share screen option.
It's not there.
Where is that share screen option?
There's still one more.
All options, you in line with your mute, start video, participants, there is an option of share screen. Please check that.
Yeah, it's not there.
Yeah, but it...
Why is that not happening?
I don't know. There should not be any problem. Absolutely, settings are...
We'll share it, sir. I have shared it with her. This ma'am is going to share with us.
No, why 2 minutes? What is the time? What is the time for?
Roland, let
Yeah.
Corrosion do that.
Yeah.
So that we can compare that. Please do that.
Yeah, I have a PDF copy. I'll share that.
You don't have the original, sir?
Original, I don't have. PDF, I have. Second. That will also do, but only thing is that moving is not proper in that. Here. 1 second, I'll just size. I'll just this size. Let him continue to try. If in between if he is able to share, I'll stop this.
What did she say?
Yeah.
Are you able to share now?
Yeah.
Yeah. Can
Okay.
you see the screen? Yeah, it is in
Yes.
screen.
Thank you.
Yeah.
Next.
Yeah, it will move like this. That is the
Okay.
whole issue.
Okay, it doesn't matter. So, ladies and gentlemen,
Yeah.
this is one of the pictures that was there seen on our Mendonça group. As you can see, it is a very unusual structure. And this is the way the structure has been built. And this is the way it is seen at night time. Next. 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 Yes. So what you saw was the side view of the St. Peter's Chapel or Our Ladies of Lourdes Chapel. This structure was 102 years old. The problem was existing for 35 years. It was a mortuary chapel on same cemetery grounds, and the municipal corporation would not give them permission to demolish it and reconstruct it. They had so many rules and regulations. So ultimately, the clients called us into the picture. And what you see here is the covering and envelope, what we have put after demolishing the entire old structure. Next. You see the length of the structure. The previous slide, please. Yeah, this structure. As you can see, the entire structure has been made with a truss designed in steel. And what you see on top, the green color, is a material which came from France. It has got a beautiful resilience, and the way in which the self-tapping screws placed the anchors into the steel frame, into the purlins, and the way in which it has been capped is really a beauty. It's so marvelous to see that. This entire structure is actually reconstructed from the ground plinth, and the whole structure together with the interiors cost us just 900 rupees a square foot. So it was a very economical work. The important thing is to show you in this particular webinar that an architect can design in so many different ways depending on how the client puts his problem forward. So here we did not get permission to construct any new walls. So as you saw in the first slide, the night view, there are no walls. The entire thing is like a cage. And even the BMC were baffled, and there was no problem. Next. You can see in some of the side views how the ventilators have been designed. You can see how the structure has been opened up to make entranceways on the side. You can see how the stone masonry wall has been slapped on to the old facade of the building, and all the apertures, all these openings have been maintained the same. Next. This is the project which we had done in the 1980s at Pedder Road for the Consulate General of Soviet Union. I would like you to draw your attention to the envelope which is starting to be made below the building. We are now at the foundation level. This plot is about 30 feet higher than the Sapphire College Road. Next. You can see in those days, there was what is called the box method waterproofing, which was with the Shahbad Ladis. This I'm talking about is in 1984, when there were no construction chemicals known in the market. There were no membranes at that time. So we relied on all the indigenous type of patents and all that were made. And you can see now how the entire building from the foundation is starting with an envelope. Next. There you are. This is the entire lower part of the building, which has been made in such a way that after putting the Shabad stones, there is an IPS which has covered the Shabad stones and which has entered into the foundation pits. Next. This is the resulting building. It is for the USSR Consulate Trade Representation. The building in the foreground is the departments where they have their offices, and the building in the background, the white building, is the one where they have their apartments. The building in front is fully cladded with Italian marble, which is having the name of Carrara, and the building on the rear, white color building, has been covered with what are known as stone tiles. Now, in the 1980s, the Russians had mentioned to us that we are going to have an RCC building, RCC frame, but the entire building has to be covered. This knowledge was there with them in those years. Next. You can see how the building has been designed. The shape of the building has been given in such a way with the windows so that from the gate, nobody can fire a bullet because this is a diplomatic site. So the walls and the type of construction is very solid, but yet it is made up of the same RCC framed construction that we have nowadays. Interesting to note is the projection of the top canopy, or what we call the crown. The water is not allowed to trickle down the buildings. Next. You can see how robust the columns are, and those are some of the Russian men. They are all 6-footers. So you can see the scale of the building and the manner in which the entire building has been enveloped in Carrara marble. Next. This is the ceiling for the conference room, which is inside. If you look very carefully, you will see a lot of devices like cameras, detectors, and all sorts of electronic devices which were installed in those days. This was made in what is known as the Jali Chapti method. This false ceiling is such that a person can go on top of it, and their secret service, KGB, and all those people can actually photograph or film whatever is happening inside the conference room. Next. Next. Okay, now we come to this building. I must mention to you that this is one building which my professor and I worked together on. This building has come up because of an order from the Supreme Court of India. Mr. Jayant Kulkarni's firm, Epicons, with Mr. Parulekar, Mr. Deshpande, and all the rest, have been working on this project, and also the project which was constructed earlier on the same government property, which was having 15 stories. So in this particular project, you will find it very interesting to notice the texture of the building outside and the detailing of the building. The chhajas on the right side of those single windows have got a different kind of a plaster, and the rest of the building has got a rough plaster. It may be interesting for you to note that both the plaster sand, the rough cast plaster and that fine plaster, has come from the same batch. What we did is that we graded it by using a sieve or a mesh, and we used the rough cast plaster to deflect the sun and the rain from hitting at the building. Now, if you can see, the building has been designed in segments. Here again, you can see the round columns which are there on the edges. Inside, there are beams. The entire boxing is made out of RCC, and there are some infilling walls of brick. Same, you can see the dead wall on the left side. Now, in this particular building, Mr. Kulkarni introduced us to many chemicals which are available. This building was constructed in the year 2012 when we got the occupation certificate. So here on all the joints between the masonry and the RCC work, We have used membranes. We have used chemicals to fill the gaps in the joints between the brickwork and the RCC work. So a lot of interesting chemicals has gone into this. Even the terrace on top has got an entire membrane. There is no brickbat coba on this terrace. The entire terrace just has a screed and a membrane. So from 2012 to now, it's about 24 years. It's absolutely looking brand new, spick and span. Next. You can see here, this is one side of the building where the entire part is cantilevered. If you look low down on the picture, you will see that there is a bracket, which is an angle bracket, and the entire boxing. In those days, this boxing was like a cupboard which was given free of FSI. As I mentioned to you, one has to use the knowledge of the law to help the client. So we maximized whatever the details were required to be incorporated into the project to give them the benefit of whatever was free of FSI. Next. This is a picture that we have taken of one structure, which is a Parsi structure, maybe more than 100 years old, just opposite the cinema at Metro Cinema. This picture has been incorporated just to show you that even 100 years ago, this technique of using rough cast plaster was there in order to keep the cracks minimized in the building. Next. This is the detail of it. It has been recently painted. And you know how the Parsi communities, they are so careful about all their possessions, even their motorbikes, their buildings, and all that they have. Next. This is a building which is under construction at Baikla for the President of India through the Indian Railways. This building has got an entire outer RCC shell. If you see, there are so many different constructions nowadays. Even buildings which are 65 stories high, they are sitting on transfer girders. The technology today that has been used by the fantastic engineers that we have is mind-boggling. One cannot imagine that you use a transfer girder which is 3 meters high or 4 meters high or 6 meters high to hold up another building which is 65 floors on top of a parking lot which is of 5 floors or 10 floors. So when you use RCC for these type of structures, it is much easier to keep the structure clean and free from moisture. As we have seen, there are so many wonderful chemicals which are being introduced, and the engineers are painstakingly trying to keep that cancer away. It is for buildings where the steel has started corroding. But as architects, we need to help the engineering fraternity and design our buildings in such a way that we do not invite moisture to come onto the structure. Next. This is a building for the John Paul II Convention Center, which we have designed at Goregaon. The foundation stone of this structure was laid a few years ago, but the clients have found it quite expensive to build this kind of structure since they are a charitable organization. So they are now looking for partners who will be able to take the lead in the hospitality industry. This building also is an entire shell kind of a structure. You can see it has got a shape like two arms welcoming you. Even the side behind with the auditoriums and the other buildings which are overlooking the Western Express Highway are all designed to look monolithic. So the way in which the chemicals can be used here will be to enhance the life of the building, because ultimately at the end of the day, today we should go home keeping the important thought of sustainability in mind. So whatever we do, any project that we have, we must work very closely with the engineers and the construction chemical manufacturers to see what we can use in our projects. Next. This is a project for the convalescent center at near Panvel. It is the property is belonging to an offshoot of the Holy Family Hospital, who are our clients at Bandra. Next. This is another very interesting envelope. In this particular project, it also happened to be a chapel and a school. The inside of it was being used by the teachers in order to train some young students. And this building was also collapsing on itself. It was more than 100 years old. Here again, they just wanted to pull down the building and reconstruct it. So the BMC told us that you cannot put RCC. If you put RCC, then the building will have to go in for redevelopment. And therefore, what we did, as you can see in the next slide, is that we have built an entire load-bearing structure shell outside the building. And the most interesting part is while this building was being constructed, also as a charitable building, the client mentioned to us that he could not garner enough funds to do the plastering of the building. So we were perplexed, but we called the team of workers, we brought the breast masons, and we asked them to use good bricks and to pestle the joint between each successive brickwork. And with the mutia, they pestled it in and they made the plaster and the mortar so good, so strong, that one company which was making these construction chemicals came to our rescue, and they got a product which has got elastomeric properties and is also like a paint. So if you see, this entire building has been covered with this elastomeric skin, which is also a paint. And the villagers and everybody around, they said, you know, if you had plastered the building, it would not have looked so good. Next. This is what the building looks like from the road. Next. This is one particular project at Kolaba, which was a heritage building. For 7 years, these building people were struggling to put an elevator, and they spent 7 years. They paid 35 lakhs to the architect, to the structural engineer, to the contractor, to the lift people, and also to BMC, but nothing happened. As Priya was kind enough to introduce us as a rescue architect, many of our works are just that. We rescue projects, we rescue our architectural brethren and our clients from some projects which are stuck. We do that work also. So here somebody recommended that they come to us and we help them. So ultimately, this structure also we have made 100% in steel as a superstructure with an RCC foundation. And the entire structure has been cladded with glass, as you can see. And this is a skin which is around the metal frame. So we also had to get the approval of the Heritage Committee because this was a heritage structure. And they were very impressed. They were very happy. As you can see on the photograph on the left, the roof for the lift and the roof of this 100-plus-year-old structure, it matches so well. Next. This is what you can see as the lift. Through the staircase, you can also see the staircase. Through the glass, you can see the staircase. Now, why did we do that? Because the people who wanted this elevator were very old people. They were growing in age. And although it was a low-rise building, they were feeling quite frightened to get into a lift. So we made the whole thing glass. As you can see, the doors are also glass. So they won't feel trapped into a box. And this is where I mentioned to you that as architects, we have to be very empathetic towards people, to the clients. We cannot impose ourselves on them. Rather, we have to understand their needs and we have to understand how the structural engineers deal with it. And we have a wonderful team. Next. Oh, this is one of the new buildings which was coming up at Malad. Here again, this is a project which we have rescued through rescue architecture. The building was for the headquarters of a bank. The building came up for few floors, and then the clients called us into the picture. So they wanted us to help them out, since the architect at that time had designed the building with a glass and ACP facade. And just at that time, there was a major fire in Malad itself. And when the fire officer was through the ladder entering the building, he kicked the glass and he put his foot, and that whole ACP melted around his gumboots. It sucked him in. He fell into the fire and died. So Chief Fire Officer, Mr. Rangdale, at that time, he put a very strong message in the newspaper saying, what are these architects doing? Why are they building this glass and ACP buildings? It is so dangerous. It is so so not needed. And then the clients asked us that, what can we do? We don't want this kind of hazard for our building. So we suggested to them that let us ask the architect to have the conventional kind of brickwork, plaster, and regular type of a building. But the architect said he had not designed the peripheral beams to carry the weight of the brickwork. So we came back to square one, and we had to think of a system how to make the facade of the building light in weight, similar to what he had designed earlier with ACP and glass. And therefore, we came up with this design. We have cladded the entire building with these kind of large format tiles, and the engineering part of it is superb. Now, if you notice, this building has got darker tiles on the lower part, and as it goes up, there are white color tiles, light color tiles, but there are bands in between. Now, you will know that we have got a labor-intensive technology on sites here, and the height of every floor, although in the specification or in the working drawings is mentioned as 4.2 meters, when it was actually measured, it was found that some floors were 4.25, some were 4.15, and there was a slight difference, because when you are dealing with tiles, the tile is an entity by itself. You have to go as per the formulation of that grid. So we use those bands, those darker bands in between, in order to get something that will be resilient in nature. And so that dark band is slightly adjusted in height, so that all the white tiles which form the facade of the building give you a nice impact, and the dark tiles which resemble the tiles on the lower give you that design element. So we had to do little tricks in between. Next. You can see now on the rear side of the building where the staircase is, we have gone in for the conventional method where the brick and plaster is. Here again, we have changed the type of plaster from rough cast plaster, because this part of the building, he had designed it to have just the brickwork and plaster. You can see on the left side, there is a picture of the other side of the building and how the building has turned around in order to compensate for whatever is the changes that are there in the facade. Another thing that I must mention to you, that being the headquarters of the bank, there are many different kinds of departments inside the building. They've got 2 basements, they've got a strong room, they've got safe deposit vaults, they've got treasury departments, loan departments, and so many different departments. So it was very important for us to make sure that not only the envelope of the building protects the RCC, but even the air inside the building is controlled in order to give an environment where the humidity is not too high. So the whole building has been equipped with, which is known as a VRF system, and that system has been made like a central system for the entire building. Next. This is one of the detail which you can see. I'm not sure whether it is entirely clear, but what you see on the right side, the gray color denotes the spandrel. Down is the beam, top is the beam, and those are the 2 columns. And you can see the grid where it is written A and B. Below B, it is the opening for the window. And where you have A, that is where the mullions and transomes are, which act like a steel framing on the entire facade of the building. On the left, you can see the steel framing, which is consisting of Tata pipes, GI pipes, which are actually rectangular in shape, are fixed to the building facade. And the entire facade of the building, which has got those tiles, have got a nylon backing mesh, just in case one tile falls prey to a stone or to any clash, the fragmentation of the tile should not fall down. So there is a nylon mesh behind it, which is a reinforcement. And the entire tile together with the nylon mesh is fixed onto the steel framing with spacers. You get these spacers, which are double-sided adhesives. And after the spacer has been put in place, silicone is pumped into the crevices, and then the entire tile is kept with a metal profile and screwed in place. After the screw is put into place and it is countersunk, again silicon is put on top of the screw. So this entire facade is practically impervious. Next. You can see even the canopy of the building, we have made it in ACP materials, and we don't allow the water to enter even through the canopy. This is one of the type of drawings which our office always makes in order to give the client a three-dimensional photorealistic view before the works goes into operation. I think that's the end of the presentation.
Yeah, that's right.
Okay. So let me thank Epicons once again, and in particular, Mr. Jayant Kulkarni, for this 46 years of our association, which I think is very important to mention at this time, because the underlying word of this particular webinar is sustainability. Thank you, Mr. Kulkarni, for sustaining the Mendonca Group for 46 years and beyond. Long live architecture, long live structural engineering, long live the entire team that puts wonderful thoughts and wonderful ideas and wonderful projects on the face of Mother Earth. We thank God for the beautiful life that we have got, and it is our duty as architects and engineers to protect this life with wonderful structures. Thank you, everybody.
Thank you, Roland. That was a beautiful way to end your presentation. And friends, what a wonderful 2 hours it has been. We started with PP Pandey talking about the need to address this issue. Then Saraswati ma'am took us through so many big projects where the intervention of SECRI has saved the cancer of corrosion erupting. Then we had a small presentation by our sponsor on the products that you have today. And then we had Roland talking about, as an architect, how you can really minimize the possibility of corrosion happening in a building. Of course, we all will accept that having all said and done, there is a huge relevance for construction chemicals and construction products, which will reduce or mitigate the effects of corrosion in any building, though the design itself has to be of the type that will not allow corrosion to be an issue. So on that note, I'm not sure if we are taking any Q&A sessions. Arvind, sir, are we going to take Q&A sessions? Can you take charge of that part of it?
Yes, there are no Q&A as such. Open questions are not there, but people, if the people can write in Q&A box, then we can take some few questions.
Yes. So, Jain sir, I think we can go over to the vote of thanks. Just one note from me is that, as an architect and as a journalist, I was extremely curious about how this session on corrosion will pan out. What are the topics that will be discussed? To what extent will the speakers go into the detailing of it? And as Roland very beautifully pointed out, I loved something that he said, that if you think of any structure as an envelope, whether you come out from the inside to the outside or the outside to the inside, it's how you treat it right from the basics, and then you go to the nitty-gritties and to the detailing and to technology. So a very beautiful thought to remember, that it all comes down to human endeavor complemented with technology which continuously evolves with time. And therefore, again, I'll close by saying that what again Roland said about it being like a human body, where the bones are important, the skin is important, the complexion is important, the health is important, and therefore the whole envelope or the whole package is important. And that's why we have to work proactively to keep it healthy. On this note, Jain sir, over to you for the vote of thanks.
Good evening, everyone. Am I audible?
Yes, sir, perfectly.
So first of all, let me thank serially, but still I'm tempted to thank Dr. Saraswati to start with, because she had given us a complete insight on range of various products. Main important thing is how they develop, how a detailed research goes into development of the product, and what is the kind of a timeline they had been working on these products. Thank you, Saraswati Madam. I thank
Thank you,
Pandey. Thank you. I thank Pandeyji for giving.
sir.
Sorry. Yes, madam. No, I thank Pandeyji for giving a basis to the entire webinar, that why such kind of webinars are required and how the changes are happening. Atul Bedekar, though he had given details of the product, but not only that, he has shown the complete process of quality control and quality assurance, and what exactly the Construchem people are doing when they are introducing any product in the market. The entire detailing given by Dr. Atul Bedekar was great, and Rolin had given a complete different outlook to the situation, that yes, construction chemicals are important. They're important for old buildings, they're important for new buildings. There had been various ways of mitigating corrosion by detailing, but at the same time, we cannot ignore or look aside the importance of the construction chemical, so that, because technology you cannot stop, development you cannot stop. So ultimately, we need to have latest development and latest product, latest technological product for this corrosion purpose. Next slide. So just few words about what we do. So we do structural design, Epicons, structural design, proof checking of tall buildings, structural audit, assessment and NDT, concrete quality monitoring services, project management consultancy, architecture and engineering, and of course, we do conduct training through EFC. Even we make tailor-made training program. With this, I declare that our webinar 146 is over, and let us wait, and I'll look forward to meet all of you at webinar 147. Thank you. Good day.
Thank you. Good day. Have a nice weekend.
Thank you.
Thank you.
Thank you.
Yeah, we close it.